Okay, hello everyone. I will give the presentation about our approach in multimedia satellite task. So where we use the local information from semantic concepts to help the classifier to do to differentiate possible rules and non-possible rules in the social images. So here's also shows some examples from the training data set. So here we can see there are two classes. The first one is about road possibility, and another one is didn't show evidence about the road possibility. And for the road possibility evident images, there are two subclasses. So basically, the goal of this task is to identify the possible images and also the non-possible images. So similarly, we also follow a two-step pipeline to solve this problem. In the first step, we just use the generic scene features and put them into a SVM classifier. So there is nothing special in the first step. So in the following slides, we will only describe the methods we used in the second step. So basically, we use the local level information in addition to the image level features. So here, at first, let's do a test. Can you tell which images from here is from the possible images? Which one? There are two images. Okay, the answer is coming. Yeah. So how about now? Can you still be confident with your decision? Okay, so I think maybe most of you will think the local concepts will be the important reference for your decision. So inspired of this, by this idea, we propose to use the automatic concept detection to detect the domain-specific concepts. So namely, in the context of the road possibility, we think the boat, person, and cars will be very important for the reference. So here we adopt the concept detection model YOLO version 3 to do the automatic detection and use 3 specific concepts. And because sometimes the detection is not so reliable, so we only consider the images with the bounding box in the images, and the confidence score is above 90%. So here shows some numbers that contains the boat, person, or cars in the development site. So we can see it's almost 50% of the images include these 3 concepts. Okay, so here shows the output of the detection model. So basically, the output we got is the bounding box information from these images. So since we have got the bounding box, how can we encode the local information? So we have 3 different ways to get the local information. And the first one is very simple. We just see if there is both present in the images. So, and for the second one is directly extract the visual features from the bounding box regions. And the third one is we propose to only use the very lightweight features. So basically the visible proportion of the concepts of the car and the person. So we can see here in the second column, for the possible images, they tend to have higher aspect ratios. And for the non-possible images, it's just like a square, so with lower aspect ratios. And then, because there are larger variance of persons, so we only use the direct visual features from CNN for the car. And we use the aspect ratios properties for both car and person. So here, this figure shows by setting these 2 different thresholds, we can pre-filter out some possible images and also more non-possible images before the second step classification. So here are the summarize of the runs we submitted. So for at first we also tried the text-based approach, but as as the organizer side, people don't really talk about the road possibility in the very short Twitter text. So it's only achieved about 10% the performance. And for the last 3 runs, we used only visual features. So for the second one, we only use image level scene features, and for the run 3 and run 4, we use additional local features. And specifically for the third one, we use the aspect ratios and also the presence of both. And for the last run, instead we use the visual features extracted from the bounding box regions for car. Okay, and here show some failure examples for our pre-filtering method. Here we can see even for the non-passable images, we can also get some concepts with very high aspect ratios, because that people are not inside the water. So from these images, we can also observe that in addition to the fusion of the local features and the global features will further beneficial the classification. But here in this approach, we only use a separate local feature or global features. So we didn't do any fusion of the features. So in conclusion, in this approach, we incorporate explicit local information from 3 domain-specific concepts to yield better performance. And the fact that only slight better performance was achieved indicated that the scene features could have already kept most local discriminative information. So in the future, based on the observation that we found, there are a lot of maps or the figures in the no evidence images. So we can also use very lightweight features to filter out a large number of computer-generated images at first. And because in this approach, we didn't use any fusion of features and no any training process. So I think further we can use this kind of techniques to improve the classification. Okay, thank you.